The last topic we're gonna talk about in our nuclear chemistry journey is the difference between fusion and fission. And so they're very simple, really, but people always seem to get them confused. So fission is where you're going to tear something apart, okay? Nuclear fission is where you split apart a heavy nucleus, and so it's always going to be something big, into lighter nuclei and neutrons. So you're removing, you're using a neutron to bombard something, and then it's going to split it into two smaller atoms, and it's going to produce some more neutrons, so it can actually start a chain reaction or a cascade. So if you bombard U-235, it splits apart into krypton-91 and barium-142, and then it produces a lot of energy, including these three neutrons. The energy that you've released, as I said, can produce a chain reaction, because each one of these three neutrons can then bombard another U-235 atom and produce three more neutrons, and then those three do three more neutrons, and so eventually you're going to get to something called critical mass. And critical mass is the minimum amount of U-235 that you have to have in order to sustain a chain reaction, because you have to have enough of it to keep bombarding. So a nuclear power plant uses the amount of energy that you release in fission to generate electricity, and they do that by taking the heat, boiling water, making steam, which in turn turns a turbine, and so you generate the electricity. Just like it turns the same kind of turbine basically as if you were in a water power plant, that the coal is heating up the water and the steam is generating the energy. You just are using a nuclear reaction instead of a chemical reaction. Obviously there are dangers inherent in using nuclear power. Radiation leaks, disposing of that nuclear waste, which has got a very long half-life, so it stays harmful for a very long period of time. They minimize radiation leaks by having containment facilities in the power plant itself, as well as control rods. Currently, we put nuclear waste in the ground or in caves that are lined with clay. Not sure if that's the best method, but you really only have the ability to store it. You can't treat it and make it less hazardous at this point. So that's fission. So fission, you bust things apart, you produce a whole bunch of energy, and that's what we use in our power plants. Nuclear fusion is where you take two light nuclei, put them together, and form something bigger. And so a lot of times what you're going to see is hydrogen. You're going to take hydrogens and you're going to fuse them together, that's where fusion comes from, into something that's bigger than either of the first two, and you're going to produce energy. Now, we don't currently use fusion to produce energy because you have to be at really high temperatures and pressures in order to fuse these two together. And so one place where that occurs is in the sun. And so nuclear fusion occurs in the sun, where it's really high temperature and really high pressures, and you're constantly fusing the hydrogens together and producing the helium and the neutrons, and that's where we're getting all this solar energy from the sun. The only real application that we've done for nuclear fusion on Earth is the hydrogen bomb. And so we don't do those anymore. It's not really conducive. It's a lot easier to make the other kind with U-230, with uranium, plutonium. But fusion is what occurs in the sun, and it is the joining together, fusing of hydrogen atoms to form helium, and that's the best example of nuclear fusion.